A stem and leaf plot is a method used to organize statistical data. So it's a visual way to kind of take a set of data and see how is it all spread out, or where does most of the data lie, or are there any gaps in the data. The digit furthest to the right is used to form the leaves. You want to say it's the ones digit, but you can make a stem and leaf plot with decimals. So that's why we don't say it's the ones digit, but majority of the time it is going to be the ones digit. The other digits are used to form the stems on the left. To make the stem and leaf plot, the leaves must be in numerical order, and the smallest stem should be the smallest value and count up to the largest stem, which is the largest value. We leave the stem blank if there are no leaves. Don't skip it, because that's going to be how you tell if there's a gap in the data, and it's an easy way to pick out an outlier. If a number's repeated, you also repeat that leaf on the plot. Again, it's a visual way to represent all of the data and how they're spread out. And then we include a key, because that's going to tell anybody else how to read your data. So let's make a stem and leaf plot of the scores below. We start with stem, and leaf. I know, math teachers were not totally very creative. And we go through our data and we see we have 56. And when we look at the data, we see 56 is our smallest number. So our stem's going to start at 5, and we're going to count up. The way you know when to stop is we end up finding 99. That's our highest number. That means the stems need to go from 5 all the way up to 99. Now, just to ensure that my data is semi-organized and written neatly, I'm going to draw lines across, because I want to make sure that y'all can read it and things don't get all mixed up. We go through our list of data and we find there's a 59. So we have 56 and 59. We read this as seeing the stem is a 5, the leaf is a 6, that makes 56. The stem is a 5, the leaf is a 9, that makes 59. We don't need commas in between the leaves, because we know that in this case it's the ones digit for each leaf. So we would not read this as 569. When we go to do the sixes, we see 64, we see 65, and we see 69. Now you'll notice that when I'm writing these, I'm trying to keep my first leaves all lined up and my second ones all lined up, because this is going to help us determine which interval, the 50s, the 60s, the 70s, the 80s, the 90s, has the most data points within it. Moving on to the 70s, we actually have a 70, so we're going to put a 0. And we have a 71. And we have a 73. And we have a 76. A 77. 78. For the 80s, we actually have 80. And we look and we find out that we have an 82 at the end of the first row and an 82 towards the beginning of the first row. So we put 2 2s in the 80s column to represent there are 2 82s. There's an 85 and an 86. Up until this point, by lining up all our leaves, meaning the first ones are all aligned, the second ones are all aligned, and so on, we are able to tell the 70s so far have the majority of the leaves. Since this is representing test scores, we can say that most students made in the 70s, because most of the numbers in the 70s has the most numbers in it. Moving on to the 90s, we have 2 91s. We have one in the middle of the first row, and we have one in the second row. We have 2 92s. One is at the end of the first row, and one is in the second row. We have a 95 in the middle of the first row, a 98 at the start of the first row, and a 99 at the end of this, or in the second row. We can then go ahead and make our key, because the key is going to represent, and the key is going to tell us how are we going to read this. Now, when we write the key, you pick any number on your stem and leaf plot. I'm going to pick 73. So we write 7, draw a long vertical line, and then a 3. And we write that that means 73. Because when we see the 7 on the left, and then the line, and then the 3, that's going to indicate tens digit, line, ones digit. Notice that when I made the stem and leaf plot, I crossed them off as I went. That's just what you can do in order to make sure that you don't skip any numbers. Now we're going to use the stem and leaf plot on the previous page to answer the following questions. If you're able to lay them side by side, great, but if not, you may want to look at your stem and leaf plot while I answer these questions, and then rewind the video so that you can fill in your answers, or at least pause the video so you can fill in the answers. In looking at the stem and leaf plot, the lowest score is 56. The highest score is 99. We found that out very first off. When we counted them up, the 90s is the interval that had the most student scores, meaning that the majority of the scores were in the 90s. In order to determine how the median test score compares to the mean test score, we're actually going to have to calculate both data points. To calculate the mean, we add up all of our numbers. Whoops. And that tells us that the mean is going to be, when we add them up, we get a sum of 1,831. And there were 23 students in the class. That means our mean is approximately, because we're going to have to round, 79.6. For the median, we have to go through and find the middle value. So writing the numbers in numerical order is pretty easy to do right now, given that on the stem and leaf plot, we had to put them in order.
I'll go get some help. Fight for what we know is right. I tried that, and I failed. You must do what all great leaders do after they fail. What's that? Try again. I'll need your help. Mr. Robot.
Oh, actually, this is my bracelet.
Alright, there's all 23 numbers. So now we go through, and we're going to mark them off. Almost done. And we get 80. So our median is 80. To answer the question, how do they compare? They are very close. There is no outlier. To affect the mean. And so because there's no outlier to affect the mean, it's your median and your mean should be fairly close, and in this case they're extremely close. It's really easy to identify that there was no outlier when you look at the stem and leaf plot and see that there were no gaps in it. Line plots show the frequency of the data on the number line. The important part to know is that we're talking about frequency, which is how much something occurs. And every time a data value occurs in the data set, we're going to use an X above the number line to represent that data value. The number line has to be in sequential order so that there could be numbers left blank because they're not in the data set. Take a look at the science test scores of Mr. Bradley. He's very proud of all students in his science class because they did an excellent job on last week's science test. Everyone in the class scored an 88% or higher. The line plot below shows the score distribution, and we're going to use that plot to answer the questions below. Notice that his line plot goes from 88% to 100%. There are gaps at 92%, 99%, and 100%, along with 96%. because nobody scored those scores. So he didn't leave them off the number line, he just didn't put any X's above them because nobody scored them. Using this line plot, let's answer these questions. So the first one says, how many students are in Mr. Bradley's science class? The answer would be 27 students. Because there are 27 X's, and if you count them, you should get 27. How many students received a score of 94%? You come to 94% and see that there are 2 X's, meaning that there are 2 students. Again, to count up the number of students, you see that there are 4 at 88, there are 6 at 89, 3 at 90, 1 at 91, 2 at 93, 2 at 94, 3 at 95, 4 at 97, and 2 at 98. When you add up 4 plus 6 plus 3 plus 1 plus 2 plus 2 plus 3 plus 4 plus 2, you'll end up at 27. Number 3 says, what was the highest score in the class? The highest score would be a 98%, because that's the highest number that has an X above it. What was the lowest score of the class? The lowest score would be 88%, because that's the smallest number that has an X above it. How many students received a score in the 80s? Well, we look and there's 4 at 88% and there's 6 at 89%. That means that we end up with 4 plus 6, which is 10 students. And how many students received a score in the 90s? Well, if we know there's 27 students and 10 scored in the 80s, that leaves us with 17 students in the 90s, but we also could have added the 3 for 90 plus 1 plus 2 plus 2 plus 3 plus 4 plus 2 for 98% and gotten 17. Next, we're asked about what percent of students scored 93% or less. In order to solve this, we have to know that there are 4 plus 6 plus 3 plus 1 plus 2. We must include the 93% because it said 93% or less. That's going to give us a total of 16 out of 27 students. So we want to know 16 out of 27 is what percent out of 100. When we solve it, we get approximately 59.3%. The last graph that we're going to look at is a histogram. Bar graphs are used to compare data, while histograms are used to show the distribution of the data. Again, we're going to be talking about frequency. In a bar graph, each bar represents one data value and the bars are separated, whereas in a histogram, the bars are going to show an interval because we're talking about frequency, and the bars are going to touch. Below is a histogram that shows the number of texts students sent each day, and we want to use it to answer the questions below. Now, I don't really like how this is labeled, so we're going to cross off the labels that they've given because it's technically labeled wrong, and we're going to say this first bar is 0 to 1 text, the second one is 2 to 3 texts, then 4 to 5 texts, 6 to 7 texts, and 8 to 9 texts. So the bar should have the labeling at below the bar, not on the line between the bars, and it should represent an interval that doesn't overlap. So notice it doesn't say 0 to 1 and then 1 to 2, because if we get one text, we need to know which bar specifically is it going in instead of having to guess and put it in 2 bars, and it's just confusing. Now that we've done that, let's go ahead and answer the questions. Most students sent between blank and blank texts. Well, when we look at it, we see that the bar for 8 to 9 texts is the largest. This means that most students sent between 8 and 9 texts. Question number 2 says, how many students sent between 8 and 10 texts? Well, first of all, instead of 10, we're going to call that 9. So how many students sent between 8 and 9 texts? The answer is 5 students, because the bar goes up to 5. Number 3 says, how many students are represented in this histogram? So we need to know what's 1 plus 3 plus 4 plus 4 plus 5. And once again, we now have 17 students. If a student sent 2 texts, which bar would they be added to? So we look along the bottom and find the number 2 and find out that it's in the second bar. Now, the last question is probably the hardest for students to answer, because when you're asked to find the median number, you want to be able to locate a specific number. However, in this case, we are talking about an interval, so a range of numbers. We can still find the median, but the way that we order the numbers is going to look a little bit differently. So when we write them out, we notice that we have 0 to 1 is 1 time, and 2 to 3 is 3 times, and 4 to 5 is 4 times. So instead of writing just one number, we're writing what the actual interval is. And then we have 6 to 7 4 times. And now we have 8 to 9 5 times. And we can go through and see where's the median interval going to be. And we find out that it is, in fact, the median number is 6 to 7 texts.